next presenter is Professor Jan Uhlir of the CEZ Research Center REG, who's a Czech colleague. We look forward to understanding your current research. Yeah, the floor is yours, Jan. Please introduce yourself and provide us your insights.
Yeah. So, thank you very much, David. Good morning in the United States, good afternoon in Europe, and probably good night in Asia.
And please go to presentation mode.
Yes. It is, yeah? Okay. So my name is Jan Uhlir, and I work for the Research Center REG. Let me thank you very much for the opportunity to give a lecture at this workshop. So thank you to the organizers. To introduce myself briefly, so I work for the Research Center REG in the Czech Republic, and now my position is a senior researcher of the nuclear fuel cycle program. Prior to that, I was a head of fluorine chemistry department and the deputy director of the fuel cycle division in the Nuclear Research Institute, which is the mother company of Research Center REG. My long-term practice is mainly in the fluoride pyrochemical partitioning technologies, fluoride volatility process, and recently of those devoted to molten salt reactor fuel cycle. And concerning my international activity devoted to MSR, I am one of the Euratom representatives in the Provisional System Steering Committee of the Molten Salt Reactor in Generation 4 International Forum. My presentation to the Molten Salt Reactor workshop is about the present effort in the Research Center REG, now focused mainly to the experimental program with hot FLIBE zone at our LR-0 reactor. So this topic is because it is some part of the Czech molten salt reactor program, which has a direct link to the Oak Ridge National Laboratory. Research and development of molten salt reactor system has been studied and experimentally developed in the Czech Republic practically from the year 2000. And the program has been solved always by a consortium of Czech institutions and industrial companies. And just from the start, our activities included a significant experimental program. So our wish and our aim of the program was always to appropriately contribute to the knowledge of molten salt reactor physics, core design and safety, structural material development, and to the technology of thorium-uranium fuel cycle, and also to focus on R&D technologies applicable within the molten salt online reprocessing technology of liquid fuel, and finally to verify experimentally selected important areas of molten salt reactor technology and to solve existing bottlenecks. In the picture here is a view on the Research Center REG. We operate 2 research reactors, 2 complexes of hot cell radiochemical laboratories, and so Research Center is located in Vltava Valley to the north of from Prague. So the platform for collaboration with US Department of Energy and specifically with Oak Ridge. So this is important area for us, and some important date were in 2012 when the Memorandum of Understanding about the collaborative research and development of molten salt reactor technologies and fluoride salt-cooled high-temperature reactor technologies was concluded between the Ministry of Industry and Trade of the Czech Republic and US Department of Energy. Under this memorandum of understanding in 2013, Oak Ridge provided us about 75 kilograms of FLIBE salt containing highly pure lithium-7 isotope for a collaborative experimental program realized at LR-0 reactor of Research Center Rzesz. So to the information about the previous cold FLIBE experiments with inserted zone. So we always realized this experiments at our LR-0 reactor as a measurement of neutronic characteristics. Here is a picture of the schematic picture of drawing of the inserted zone in the reactor. So the zone was in the center, always in the center of the reactor, surrounded by the fuel assemblies. So in our reactor, we use the hexagonal lattice of fuel assemblies because it was done by the fact that here we also helped to the development of VVR reactors for our company Škoda Nuclear Machinery, which was the company which delivered all reactors in the Central Europe. So measurement with FLIBE showed finally the perfect agreement in neutron spectrum. The results of K effective were influenced by content of lithium-6. This type of measurement was done with the FLIBE in this zone, which was at the room temperature. So it means it was solid. Finally, this first group of experiments was in 2015 and 2016 evaluated by a joint group of scientists from Research Center Rzesz and from Oak Ridge National Laboratory. So here I have a picture of my colleagues and colleagues from Oak Ridge. So my colleagues are here, and from Oak Ridge this time it was Jeff Powers and Nick Brown. The collaboration was finalized by laboratory reports of CV Rzesz and Oak Ridge National Laboratory, joint journal articles, and joint conference presentation. So the current status of Czech R&D in molten salt reactor technology is based on the fact that we now solve new domestic molten salt reactor project, which is under realization from 2017. Project is granted by the Technological Agency of the Czech Republic and supervised by the Ministry of Industry and Trade. And the planned collaboration with US partners is an integral part of the project. Project covers reactor physics and neutronics of molten salt reactor system and fluoride salt cooled high temperature reactor systems, molten salt fuel cycle, including the liquid fuel processing, material research and development of components for applicable for molten salt reactor technology or fluoride salt cooled high temperature reactor technology. So also this project is solved by the consortium of Czech industrial companies and research companies. The most important for us is the collaboration with the Škoda nuclear machinery, which is now responsible for development of impellers and valves. Also the company MECO, responsible for flange gasket systems, and the company Comtes, responsible for further development of nickel alloy moniker. This is similar to Hastelloy N. We have running experiment program, and you can see here, for example, the FLIBE loop for testing of impellers and valves, and freezing valve also. Yeah. In addition to the main FLIBE research, we used our LR-0 reactor also for the other experimental measurements focused on the molten salt reactor physics and neutronics. And here is the drawing of the reactor and view into the core of the LR-0 reactor. So the principle always was that in the center was some inserted zone, yeah, and the fuel, standard light water, VVR fuel, was a driver of neutrons for this zone, which was always inserted in the center. Well, so present research and development of the neutronics, which arise from Memorandum of Understanding. Now we plan to realize the second series of experiments with FLIBE, which is now under preparation with the new hot inserted zone for the LR-0 reactor. And the experiments are focused once more on the molten salt reactor and FHR reactor neutronics measurement at the working temperatures of MSR system. So it means for the range, temperature range, 500 to 750 centigrades. Yeah. So now the aim is to determine the feedback temperature reactivity coefficients at the working temperatures of molten salt reactors. Here is the schematic drawing of the system, yeah, with the inserted hot FLIBE zone. So instead of the previous measurement, when the inserted zone was here only, instead of only one fuel assembly, now the inserted zone will be here instead of 7 fuel assemblies. So the zone will be much more bigger and will contain approximately 70 kilograms of FLIBE inside. How we plan to realize those experiments? So the way to perform the experiments will be following. Yeah. So after we fill the container by FLIBE, yeah. So the first, it will be preheating of the new FLIBE container in the oven outside the reactor to about 800 centigrade. Yeah. So it will be the first step. Then we must take over the container from the oven, yeah, and insert the container. This is here, yeah, into the insulation vessel, yeah, and then into the experimental channel, which will take space of 7 VVR fuel assemblies. So after the insertion and connecting with necessary instrumentation. There will be insertion of the experimental channel in the central part of LR-0 reactor, yeah, and we began with the pumping of water into reactor to reach the criticality, yeah. So the series of measurement will be done at several temperatures by gradual cool down of the salt in the container in the LR-0 reactor. And typical time for individual experiment will take approximately 2 to 4 hours. So here is some engineering drawing of the system, so of the zone and of the experimental channel. Well, so as I mentioned, the position of the zone will be in the center of the reactor core. So the preparation of experiments with the FLIBE hot zone has been and is relatively very demanding for us. And I would like to say that such as experiment with hot inserted material have never been carried out in our experimental reactor. So in order to place the FLIBE zone in the reactor, we had to completely reconstruct the lower part of the reactor core, because the zone must automatically be firmly attached to the reactor so that it cannot float out when the reactor is filled with water. Yeah. Of course, we had to apply for the approval of the State Office of Nuclear Safety. It is Czech regulator, yeah, to enable the active experiments, yeah, with the zone. So the current status is that the complete inserted zone and the whole experimental test program with new zone is now under the approval process of the State Office of Nuclear Safety. Yeah, and I would like to say that all main components of the zone just were manufactured, and now we start the cold experiments at the beginning outside the reactor, yeah, and also the cold experiments inside the reactor, but at the beginning without the FLIBE, yeah. So after successful verification, yeah, so we will have this approval from the State Office of Nuclear Safety. So to the conclusion, yeah. So all apparatuses of our hot FLIBE zone were already manufactured, and the cold experiments with the zone just started. So to launch of actual hot experiments, we planned for the next year. And my information for Oak Ridge National Laboratory and for US Department of Energy, we would like to invite our Oak Ridge colleagues again to participate in the experiments and their evaluation. So unfortunately, current contacts are now being negatively affected by the coronavirus pandemic, but I believe that this pandemic will be overcome next year and the traveling will be possible again. So I firmly believe that we will be able to continue in our collaboration. So thank you very much for your attention, and I look forward to the future collaboration.
Thank you for your presentation, Jan. We look forward to continuing this, and we are pleased you were able to present here. And we also look forward to the virus being over as soon as possible. Unfortunately, we have used up all the time. But there is a question in the Q&A box. So hopefully you'll be able to answer that